The aircraft A with radar detection equipment is flying horizontally. So this is flying horizontally, this airplane. And at an altitude of 12 kilometers. It means that 12 kilometers is the distance from here to the Earth. This is the Earth. I just put E here. And this is 12 kilometers. And the other one is 18 kilometers. So here to here is 18 kilometers. And is increasing its speed at a rate of 1.2 meter per second. So the acceleration is 1.2 meter per second squared. Remember, here is the second, here is second squared, because we are talking about acceleration. Its radar locks onto an aircraft B. Now it locks at this aircraft, and in the same vertical plane. So it means that both of them are in the same vertical plane, on the same plane. If A has a speed of 1000 kilometer per hour, so you need to convert this one to the meter per second, because we are talking about meter per seconds here. Okay, divided by 3.6. At the instant when theta is 30 degrees, so this angle when this theta is 30 degree, determine the values of r double dot and theta double dot at the same instant if B has a constant speed of 1500 kilometer per hour. So it means that the A for B is 0. Okay, but we have, and we know that the VB, the velocity of the B, is 1500 kilometer per hour. Okay, so remember, we have VB and VA. Both of them are in these directions. One of them in this direction and one of them in this direction. So VB minus VA is this 1500 minus 1000 divided by 3 over 3.6, which is this. So we know that the VB minus VA is this one, is in this direction. And if it is R and it is theta, R dot is always in these directions, and V theta is in the direction of when the theta is increasing. Theta is increasing, remember, this way. So we also can we can also resolve this vector into r dot and r theta dot. And since we know the angle, we can easily do that. It will be here VB over A cos 30 r dot, and the other one will be sine theta, but it is minus, because always remember the positive one will be this way. Sorry, I mean these directions. This is the positive for r dot, this is the positive for r theta dot. So, and again for AB over A, we know that AB is equal to 0, as I said, and AA is 1.2, so the result will be this. And again, we decompose that. First, you need to draw this here, which is this vector. And as I said, we always know that r double dot minus r theta dot squared will be in this directions. Okay, but since if we decompose that, it will be in this direction, so it means that this is negative. So we just need to substitute the number r. We have the r. It says that in the question r is 12 kilometers, or maybe I'm mistaken. Yeah, we have r here, so because this is, if this is, why this is not working? Okay, when here is 12 kilometers and here is 18 kilometers, therefore from this point to this point is 6,000, and since this is 30 degree, this will be 12 thousandths. So r will be 12 thousandths. Okay, 12 thousandths, and theta dot, we have already obtained that here in the previous equations. So we just substitute this, and r double dot, we need to find it. And again, for r theta double dot plus 2r dot theta dot, AB over A in theta direction after decomposing. This is ABA, as I said. And in theta direction, it will be this way. It is positive. And we obtain that. We have R again, which is 12 thousandths. We don't know how much is theta double dot. 2 R dot, again, we obtain it from the, we have already obtained it before, 120.3. And theta dot, again, we obtained it before, and we substitute and we obtain the theta double dot finally.